All right, so back in it this week. So we have some fun stuff to look at for our homework this week. And something that I think is going to continue to help us is in our equations, we're going to put a circle in our word problems for our constants. And we're going to put a box around our variables. And I'm going to try and do a better job this week of including keywords that will help us understand if the numbers will be positive or negative in our equations. So this first one, it says, what equation represents this solution? Miss Sellers' bank account is $120 overdrawn, so she deposits $15 each day. So I see this 120, but I also see that word overdrawn. So overdrawn means that she took out more money than she had. So that would be a negative amount of money. And then because of that overdrawn, she decided that she's going to deposit $15 each day. So depositing means giving money to the bank, to her bank account. And then Mr. Campbell's bank account is not overdrawn. So we know that his money that he has is going to be a positive amount, and he starts at this positive 180, a balance of 180, and then he deposits, so he's also deposits $12 each day. So in this equation, we have a negative 120 as a constant, so we don't have any variables, and then we're adding a $15 a day. And then this is going to be equal to a positive 80 and a deposit of $12 each day. All right. And this one just says what equation represents, so make sure we're reading our question. So if we read our question, we know we can stop right after setting it up. Whereas in here on this one, it says to solve it. So I always like to draw my line, and a term is a piece of the equation. So we have a couple different terms here. We have a 3.2x, a negative 4, a 5.2x, and a positive 10. So throughout this homework, I'm going to be highlighting my constants in yellow, so when I can't circle them, and my variables in green, so we can see what our like terms are like. So my constants are going to be in yellow, and my variables are going to be in green. So remembering that a constant is equal to a number without a variable, and a variable is an unknown represented by a letter. Okay, so going back to this, we have two constants and two variables, but they're not on the same side, so we're going to be able to skip to step 2. So step 1 was combining like terms on the same side. So since we don't have like terms, we're going to move to step 2. And since we have variables on both sides, we're going to find our least coefficient with the variable. And we're going to move it to the other side by doing its inverse. So my two coefficients are 3.2 and 5.2. So since 3.2 is smaller, I'm going to do the inverse and move this. So on this side, this will become 0, and we'll be left with a negative 4 equals 5.2 minus 3.2 will be 2 minus 2 is 0. We have our x. And 5 minus 3 is 2. We'll have 2x plus 10. And now, step 3 is to see if we have constants. And since we do have constants on both sides of the equal sign, we have to find the constant on the same side as the variable and move. So the one on the same side is going to be this positive 10, and so we're going to do a negative 10, or subtract 10, so that this will zero out, and we'll be left with negative 4 minus 10 will be a negative 14, and that's going to equal 2x. And our last step is to divide both sides by coefficient. So we're going to divide both sides by 2, and this will become 1, and we'll be left with x equals, and make sure we simplify everything. Alright, so place the following numbers. So just to review up here, this is the real number system up here. So to review the definition of each of these numbers, we have our natural numbers are counting, so we're going to be 1, 2, and positive infinity, no decimals. And then our whole numbers are going to be from 0 to positive infinity, also no decimals. Our integers, we're going to start including our negative numbers, no decimals as well. And then our rational numbers is going to include our fractions, decimals, but important, the decimals that are here are patterned or terminating. So now to place the following numbers in the correct category above. So what I like to do is, first I like to turn everything into a decimal. So this one, we got it, it's already 6. So the square root of 9, so on the calculator, when we want to find the square root, we're going to push the second button and then the x squared, and then it'll give us our square root, and then we can put in our box that we're looking for. So the square root of 9 is actually just 3. And so all of these other ones look like they're already simplified. So when we look at these, we know that 3 is a positive number that would also be a natural number, or the square root of 9, since they're the same thing. And then this negative 5.1212, since this is a pattern, we're going to be able to include that in the rational. And then this 1.43, also a terminating decimal, so this could also be a rational. And just to point out, I want to erase this really fast and just remind you that the natural numbers can also be a whole number, and then the whole number and natural numbers can also be an integer, and the integers can also be rational numbers, but these arrows are only one direction. So as we put these numbers in the specific boxes, we need to make sure that we know that negative 6 is an integer, but negative 6 can also be a rational number, but negative 6 cannot be a whole number. So this one is correct, but it cannot be a natural number, nor can it be, or it can be a whole number, it cannot be a whole number or a natural number. Okay. Okay, how many constants are in this problem? So our constants. We have constants up here at the top. Constants are numbers without a variable. So we want to find, we have our terms in this equation. So these are my terms, but which ones are my constants? So I'm going to go ahead and do a little bit of highlighting, remembering that our constants are in yellow. And we can see that constants, numbers without variables. Alright, so here, place these numbers in order from least to greatest. So we're going to go from smallest to largest, and once again I like to make sure I simplify everything so that I know that I am working with my simplest numbers. My least one, making sure least, knowing that on a number line, so if this is 0, make sure this way is greater and this way is less. So somebody pointed out to me that this looks like a less than sign, less than, and this right here looks like a greater than, to help you remember. So as you see those numbers, make sure that you include the negatives and positives. And just to start out, my least number is going to be the one that's furthest away from 0. So the one that I see is that's furthest away from 0 is going to be that negative 3.1212. And then keep going. Alright, so which number can be found in the most boxes? The most boxes. So, as we refer to up here, I just drew a star up here. The natural numbers can go out, but the rational numbers can't go in. So we're going to want to find the most inner box to be able to determine which number can be found in the most boxes. Alright, so now we're going to go look at our coefficients. Coefficients. So as we look here, coefficients, constants are numbers without a variable. Coefficients are our equal numbers with the variable or attached to the variable. Alright, so what is the definition of an irrational number? An irrational number. So in our notes, there was a definition that we were able to look at, and you'll be able to define that for me and Mr. Campbell and Miss Doherty. Now, which categories can have decimals? So, once again, referring back to this chart right here, we'll be able to answer this question. Convert these, okay, looking at Thursday, convert these to decimals. Okay, so this is where your calculator will come in handy. So remember again, to find the square root, you'll push the second, and then the x squared, and then you'll get your box, and then enter the number, and convert these to decimals. So all of these will be able to do this on the calculator. This is a little bit different right here. These two are going to be being multiplied. And here again we have a numbers in order from least to greatest. Least to greatest. So we have least, less, if this is 0 to greater. So make sure we could turn these into decimals. And now, which sign solves the inequality? So we're given an option of a less than, greater. So based on these numbers here, we're being asked to turn these in. So what I would recommend is turning these so 7 divided by 8. So this sign here equals division. 7 divided by 8. So this equals 0.875, and then we're asked to do our inequality of 8 divided by 9. So this one is 0.8 repeating. So then determine whether 0.875 is less than or greater than 0.8 repeating. And the same thing here, which sign solves the inequality? So this one or this one, we can turn these into decimals. And there's a lot of new words, but make sure that you are trying your best to look at these videos, and I hope that they are helpful. One thing I want to point out, and is an irrational number cannot be written as a fraction. So, side note for that, and I hope this helps, and I hope that everybody has a great week.